CH double bond CH2. This is propene, and it is an example of unsymmetrical alkene. It is an example of unsymmetrical alkene since the double bonded carbon atom consists of unequal number of hydrogen. So when it interacts with the HBr, it is also unsymmetrical reagent in presence of peroxide, and on heating a special type of reaction occurs, and that is known as anti-Markovnikov's addition, or this is better known as cross peroxide effect, better known as cross peroxide effect. And according to this rule, it has been stated that whenever an unsymmetrical alkene is interacts with the unsymmetrical reagent, then the positive part of the reagent is attached to that side of the double bond carbon, which consists of minimum number of hydrogen atom, and negative part is attached to that side of the double bonded carbon atom, which consists of maximum number of hydrogen atom, and this is only happen when the reaction is carried out in presence of peroxide. So the product will be CH3, CH2, CH2Br, and this is N-propyl bromide, and it is Br attached with the CH2, so it is 1 degree haloalkane. This is 1 degree haloalkane. Now move on to the next part of the reaction, free radical addition reaction, that how it is mechanized. Every reaction which are taking place by the help of free radical occurs in three different states, which are chain initiation state. The step involve the formation of free radical. Second step, chain propagation step, and this reaction involves interaction of the free radical with the reactant molecule. And you should remember one fact, that in chain propagation state, both reactants and both reactants and the free radicals interacting together results the formation of product as well as the byproduct. And the last step, which is known as chain termination step, the step involving the combination of free radical to stop the chain reaction. Let's see how it occurs. The first step is chain initiation step. First step is chain initiation. Now let's see how the free radicals are generated. At first we have to consider peroxide, and on heating homolytic bond cleavage occurs, and alkoxy free radical generated, and then this alkoxy free radical interacts with the HBr, and this is RO alkoxy free radical interacts with the hydrogen, form ROH, and then Br free radical is generated. So this state is known as chain propagation state. Chain initiation state. And then we are in the next step, that is chain propagation. Chain propagation, what we need to do, we have to take a reactant molecule, that is alkene, and its interaction with the Br free radical. There are two ways by which Br free radical can interact with the propene. Pi bond electron shifted on each of the double bonded carbon atoms singly. So Br can attach this position or this position. Then what will happen? CH3 CH Br. If we attach the Br radical on left side of the double bonded carbon atom, then we are getting this free radical, and this free radical carbon consists of one adjacent carbon, so it is 1 degree. And now if we attach right hand side, then it becomes CH3 CH CH2Br, and we are getting 2 degree free radical. Always higher degree free radicals are stable, so we have to choose this one, and this state is considered as slow state. And then in the next step, CH3 CH free radical CH2Br further interacts with the HBr. Then what will happen? This free radical carbon interacts with the hydrogen atom of HBr and results the formation of CH3 CH2 CH2Br, and bromine free radical is regenerated. So we have generated the main product, and that is N-propyl bromine, and the second step is very fast. Now at the last we have chain terminating step. Terminating means the removal of the chain growth by combining the free radical. So we have generated Br free radical, both are interacts together and form Br2. So this is the different steps that we are involving to explain the free radical addition reaction. Hope you understand. And with this free radical addition reaction, one topic is we have already completed, and that is anti-Markovnikov's addition, which is just reverse of Markovnikov's addition reaction, and it was first of all explained by Kars, so it is also known as Kars peroxide effect. And such type of reaction only occurs when the reaction takes place in presence of the peroxide. So many a times a question can be asked in your examination that write notes on anti-Markovnikov's addition reaction. And one thing you must remember, that this reaction is not shown by HCl and HI. In today's class I am not going to explain that why this reaction is not shown by HCl and HI. you must try to solve it because all of you have gone through this topic in your preliminary classes. So if you have good concept, then you can solve it. Otherwise I will explain this particular topic in our next segment. Till then, goodbye.